These are called the power of the point theorem. Situation 1 is different, but situation 2 and 3 are almost identical, even though they look slightly different. Words that are inside of a circle like that, you just multiply the two pieces of the same segment together. So you can see that A and B are the same chord. Can you guys see that? A is one part of the chord, B is the other part of the chord. So you're going to do A times B equals, and then C and D are part of the same segment, so you're going to do equals C times D. So that one's pretty easy. Pretty easy formula there, okay? Then for these other ones, here's how I remember it. So I don't do it based on these letters because I think they're confusing. So here's how I remember it. I think the entire length multiplied by the outside portion, maybe is how I'll think of it. The entire length multiplied by the outside portion. That's how I think of it, okay? So now let me go ahead and kind of explain it for the two specific scenarios that we have. So the way that it works is the entire length, so we have two secant lines. Remember, secant lines cut through a circle. They cut through 2 points of a circle. So the entire length would be x plus w. Does that make sense? You have x is the portion inside the circle, w is the portion outside the circle. You see that? So the entire length would be x plus w. So we're going to say x plus w times w. W is the outside portion. Does that make sense? The entire length times the outside portion equals the entire length, which is z plus y, times the outside portion, which is y. So the entire length times the outside portion. Does that make sense?
Is it only for that, like, exact shape?
It works for the other one too. Which you'll see in a second, because you'll be like, but this one, the length is the outside portion? To which I say, yes, exactly.
So you just plus it by itself?
Yes, exactly. Yes. Okay, so let's do the next one. So we're going to say I'll do the bottom part first. So the entire length is z plus y times the outside portion is y. All right. And then for this one, what's the entire length? T. And then what's the outside portion? T. So it's the entire length times the outside portion. Yes?
Why do you not do t plus t?
Because it's technically, if you think about the entire length as like the part outside and the part inside, you would say the part outside is t, the part inside is 0, because there's nothing inside. So it's kind of like t plus 0 times t. Does that make sense? Okay. So we do the entire length times the outside portion. So some students are really big on like, oh, I draw the diagrams and I figure out what the letters are and then I try to match that up to the exact problem. And I say, no, 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 that's a very difficult way to do the problem. The easiest way is to just think of it as the entire length times the outside. And then you don't have to memorize a formula, you just memorize how the formula works. The entire thing times the little bit that's outside the circle. Okay, so let's write this down. So I'm going to say we've got a 6 and an 8, so let's figure out what the entire length is. What's the entire length if you have a 6 and an 8? 14. Okay, whew, that was a long pause, but we warmed up our brains and we got it figured out. All right, and then this one we have to work a little bit harder. If we have a 7 and a y, the entire length is not 7y because that's multiplication, and we are adding them together. 7 plus y. Marvelous. Okay, so we're going to say the entire length of 14 times the outside portion. so times 6, equals the entire length of 7 plus y times the outside portion of 7. So we did the entire length times the outside, the entire length times the outside. All right, how do your brains feel? Make sense? Okay. These are making sense. Okay. 14 times 6, anybody? 84, okay. And then 7 plus y, and we just got 7. Okay. And then what should we do? Subtract the 49. So it's 35 equals 7y. I wonder if I focus this smidge. Okay. What should I do? Divide by 7. Y equals 5. All right, next one. So we've got the entire length, which is 24. Okay, so we got the entire length times the portion outside the circle equals the entire length, z, times the portion outside the circle. Okay, so 24 times 8. Okay, 192. What's z times z? Z squared. Okay. And then what do we do to solve for z squared? Square root. Okay. So now, since we are the ones square rooting, how many answers do we have? 2. We're going to say z equals plus or minus. What's the square root of 192? Okay. And then only one of the answers makes sense. We have to write both of them down because we are mathematicians, we do things correctly. When you square root an answer, you do get a plus minus. Because if you don't get a plus minus, then you kill a baby horsey, which I do not have on the dead baby animal wall, but it's there. See the sticky note? 19 of them have died from Honors Math 2. Yes. May they rest in peace. So baby horsies die when you do not put a plus minus when you square root. No, it's an extraneous solution, but we are mathematicians, so we do the math. We recognize there's 2 answers, and then we recognize that in the context of this problem, the negative answer does not make sense. See, but we do solve it correctly. We solve it correctly, and then we say, oh, one of them does not make sense. Yes? No, in this instance, we do the math. We say there's 2 answers, and then we say, oh, only the positive answer is good. No. No, it's never fine to kill a baby horsey in a math problem. It's not like, oh, that mistake worked out. Oh, that accidental murder was profitable. No, we don't go that route. We are not those people. We are not those people. All right. How does your brain feel about this problem? Okay. So we're going to say negative version is extraneous. Do you guys remember that word? Negative version is extraneous. So it's an answer you can mathematically solve for, but it doesn't work. That's what an extraneous answer. Mathematically, you can solve it, but it doesn't work in the context. All right, last page. 2 more examples. All right. So we're going to do the entire length, which is 34, times the portion outside, equals the entire length. What's this entire length? X plus 16 times the portion outside. Okay. What is 34 times 14? Okay. And then what is 16 times x plus 16? Okay. All right, so what do we do now? So what do we get on the left? 220. Okay, 220 equals 16x. And what do we do? Lucas, that nail color looks real good on you. You're welcome. Yeah. 220 divided by 16, isn't it evenly? No? Okay. Well, it's still a pretty nice answer. Okay. All right. Let's do number 13, finishing the worksheet on Lucky 19. It hurts. No, I'm pushing on my skull because my head hurts. Yeah. I'm an alien, and sometimes my skin gets a little bit off. Okay. All right. On. What are we multiplying together? What's 3 times 7? 21 equals 6.5m. And then what do we do? I'm really mad at whoever wrote this problem. It was not me. Why couldn't they just make it 7m? I guess. So n is approximately what? 231, you said? Oh, there we go. All right. Notes are set. We've got them all done. The worksheet is kind of like yesterday where it had sections that kind of match the sections of the notes so that you can work on, you could work on the stuff we just did, or you could work on the stuff earlier in the notes. The answer key is already in the back because I had a productive third period today. Are you enjoying the Bitmojis? We have a forest theme today. Oh, that's okay.